minutes of solid time, we should be able to do this. Okay, so we're gonna take a look at lesson 4, an application of linear function. So in this particular case, there's a meaning for x, there's a meaning for y, and that's the reason why we're here, right? We're here, we're trying to figure out how do we apply the math into real life? How do we apply math in, yeah. So in this particular case, we're gonna focus on linear functions. We'll go as far as we can. So it says here, Maya is making necklaces for a craft fair. Okay, necklaces. This is on page 26. It cost her $2.50 to make each necklace. Okay, focus on that one. Let's see here for a second. $2.50 each necklace. So that kind of tells us it's $2.50 per necklace. So that's what it means. $2 for each necklace. It means $2.50 per necklace. And she needs to pay $49 to rent a table at the craft fair. So in this situation, it's modeled by this formula. So C is equals to 2.5n plus 49. So what does the C represent? The C is the cost. Okay, total cost in dollars, of course, because its cost is dollars. And an N represents the number of necklaces. N represents a number of necklaces. Okay, so there's a context to this. Let's type this in onto our calculator. So Y equals to 2.5x plus 49. Let's do that. I already cleared my calculator, so it's done. At this particular point, no one's asking me how to do this anymore, right?
No.
Everyone should be good. Otherwise, I'll be like, yeah. Okay, put that in. Now, you probably want to make sense of this question. So sometimes it helps when I do this part here. X is number of necklace. And then this is a cost, right? So how do we figure out the table? The table of values. Your calculator could do that. How do you do it? Second function, graph. Very good. You've been practicing. So second function graph. Second function graph. That gives us a table of values. So what does that say? 0, $49, 1, $51.50, 2, $54, 3, $56.20, $56.50. What do you think is happening? Increasing by how much? 250, right? And that's our rate of change. That's our slope. It's going up by 250. Each necklace is 250. So I think if we start with this table of value, if we start with table of values, that would also help us with how we're gonna set up our X min, X max, Y min, Y max. Yes? Does that make sense? So you look at this one here. I look at my X, which are the number of necklaces. Well, what are the values that I could use? Can I have negative necklaces? No, we can't have negative necklaces. So where do you think we should start? X min could be, well, we could go 0, right? Yeah. That means not making any necklaces. X max, well, X max could be anything, right? Could be anything positive. Now, let's go let's make 10. Right? Let's see for now. Up to 10. Now, what about the cost? What about the cost? Y min, what would be the Y min?
49.
49, right? Because as you can see, it's not going to get any lower than 49. So we can go, if you leave a little bit of space, we can go by 40, right? So you have a little bit of space, so you're not starting right at 49. And then Y max, okay? Y max, I'm going to go back in here. Okay, if I'm going to go X up to 10, what is the max for that one? 74. 74. So what I could do is I can make it a little bit more, 80. So I have a little bit room underneath and a little bit room above. This will help us figure out where our graph is, right? Because if I don't change my X min, X max, this is what I'm gonna end up with, right? Then you're thinking like, what happened to my graph? I gotta change the window. And then this is what you're kind of thinking about. Okay, where's my window? The reason why I can't see it is because I gotta change my window. So let's go ahead and change our window. So window, I'm gonna go from 0 to 10. 0 to 10. Okay, so 0 for X min, 10 for X max.
X scale.
Don't worry about the X scale. Yeah. Y min, I'm gonna go 40 to 80. Y min is 40. Y max is 80. Does that help you a little bit trying to figure out where your graph is? But that should help you, right? That should help us get started. Now press graph. Don't worry about the scale. We'll figure out the scale later. There you go. There's your graph. Okay. So sketch the function. Now, what's important in the function is that, what are the important things in the function? The graph. We need the x-intercept. We need the y-intercept. Because this is linear, those are the only two things that we need. Now, our x is represented by number of necklace. Number of necklace. And then the y is cost in dollars. Okay? What should I go up by? If I'm gonna go 0, 1, 2, 3, 0, 1, 2, 3. Y min, I'm gonna start at 40. So I'm gonna make a break on my graph. Start at 40. I need to go up to 80. Okay, this is your graph now. You can do whatever scale you want. So 40, 50, 60, 70, 80. Okay. Make a graph. Extra labeling is required to show the shape, the scale, and context. So we've shown this part in here. Now, the x-intercept, I'm going to show you back in here. The x-intercept would be some negative value. So does that make sense to us? Because there's a meaning to this now. X-intercept, that means we're gonna make negative necklaces. Is that even possible? No, we can't make negative number of necklaces, right? So the x-intercept, that is not relevant. But what can we do? Well, we can figure out the y-intercept. Y-intercept is that one. How do we figure out the y-intercept? You're gonna go second function, trace, 1 value, And then we're gonna put x equals to 0. Very good. So our y-intercept, as you can see, it's blinking there. It's 49. So where's 49 here?
We just press enter after.
Yeah, enter. 49. And then the next one, right there, 0, 49, and then 1, 50, 51.5, 51.5, 2 is 54. So now your graph is going to increase that way, right? So this is your y-intercept 0, 49. That's a y-intercept 0, 49. What does that mean? If the cost, she makes 0 necklaces, it would still be $49 because she has to pay to rent a table at the craft fair. Okay? Is that okay? We're not guessing our we're not guessing our window here. Now let's take a look at this one. Find Maya's total cost if she plans to make 200 necklaces. So how much would it cost to make 200 necklaces? What can we do? What can we do?
5 times 200.
Yeah, so we could do that. Yeah, we could figure that out algebraically, right? So I'll show you that. So C equals to 2.5 times 200 plus 49. Okay, this is easy enough. Everybody could do this, right? To get out of there, you go second function mode to get rid of that. Second function mode to quit. So 2.5 times 200 plus 49. Okay, so it's gonna cost her $500 and $549. So cost is $549 if she makes 200 necklaces. Is that okay? How do you do that on a calculator? That's not bad, right? How do we do that on a calculator? What can we do? Maybe next time just move up and that makes it easy for you. So how do we do that using our calculator? What can we do? Second trace, and then we're given the x value, right? X value is 200, so 1, 200. What do you expect to get here? When you do that on a calculator, you're gonna get error. Okay, now I don't want us to get like, what's happening here? What do you think we need to do? Change your window. Because remember, our window only goes up to x up to 10. But we're calculating up to 200. So window, clear that. So window. The funny thing about this calculator is the only thing you need to change is the x. You could change your y too. Yeah. You can change your y.
You change it to 500.
Yeah, I changed it to 500. Yeah. So second function trace. And then, second function trace, 1 for value. Now I can put in 200. So 549. So we can go second function, trace, and then 1 for value. And then you're going to enter x equals to 200. But we note, I'll just put over here, just for the sake of the people who are not here. Note, we must change the window on our calculator. How do you like that? Is that okay?
You should the window 500 what Alice puts the window.
Oh, x max is, I put 200.
And Y max 500.
Yeah. Yeah. Okay. Is that good? Is that better? Can I move on to the next? Okay, let's take a look at number 2. Example number 2. Ahmed starts the week with $165 and spends $850 per day. Okay, pay attention to this one. $850 per day and spends. So spend, when they talk about spending, is that a positive or negative? Negative, because it's getting less and less and less, right? So that's going to give us $8.50 per day. So that's our rate of change, and it's negative. Negative because it's spending. We're losing money every time we spend. So where D is the number of days and L is the leftover money. Okay, leftover money. So let's go ahead and type this in onto our calculator. Okay, now before you start graphing this thing, okay, you want to make sense of this question. Okay. So let's take a look. Before you graph, let's go second function, graph. Okay, oops. You go second function, graph, for table of values. This is gonna be helpful for us. Oh, that doesn't look like table of values. Okay, so what does a table of values look like? Can I go negative days? No? Can I? So the days should be 0 day, 1, 2, 3, 4, 5, right? So number of days. So we can't do a negative number of days. Oh, feel free to move up if you can't see, okay? So otherwise it's gonna slow you down. Yes, feel free to move up. So 0, 1, 2, 3. Okay? And then L is leftover money. So 0 days, Ahmed has 165. 1 day, because remember, he's been spending 850, so now it's 156.50. 2 days, it's gonna be 148. 3 days, 139.50. Okay. Now, what's the pattern in here? This is gonna be a linear pattern, right? It's linear, slope going down because the money is getting less and less and less. So let's take a look. Okay. So on the x-axis, it's gonna be number of days. And then on the y-axis, leftover money. Okay. Based on this information, what would be the appropriate x min and x max? What do you think is the x min and x max?
X max 0, or X min, sorry, 0.
X min is 0, that makes sense, right?
X max maybe like 5 or 10. Maybe
Okay,
5.
let's maybe 10. Okay, let's go 10. We could adjust it later, right? Just because we do this right now, that doesn't mean that's how it's gonna be forever. We can adjust it. Okay, for this one here, if we go to the 10th day, what would it be? 10th day. Oh, it's gonna be 80 bucks, right? Okay. So Y min, Y max. What do you think the Y min is gonna be?
80,
Y min is 80. And what's the Y max?
165.
165. Okay, 165. Is it okay if we go 170?
Yeah.
So we can just go increments of 10 later. Okay, good. So let's from here we could. Does this make it easy for us to see our graph? So we can go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh. Okay, let's see. So 0 is 165. We'll go. Now this is kind of interesting because we know that in this particular case, it's gonna go down this way, right? Is that okay? It's gonna go down, and it will have a valid x-intercept. Does that make sense? This one will have a valid x-intercept. What do you think the x-intercept is gonna be? Let's change a window. I haven't changed a window yet. So window is 0, 10. Y min is 80. Y max is 170. Okay. Now this, can you see in this particular case, there's like little tick marks there. Those are just the scale. That's not the x-axis. That's not the x-axis. So what we should do is, because this one here has a valid appropriate x-intercept, we're gonna choose a Y min of 0. Okay, a Y min of 0. So Y min, we're gonna choose a 0. I'll show you why. keeps going down, keeps going down, keeps going down. Can we see the, sorry, not the x-intercept in here? No. Well, what can we change so that we can see the x-intercept? Yeah. So we're gonna change the window. Are we gonna change the x min, x max, y min, or y max? X max. Okay. Yeah, x max. What should we change x max to? So right now it's 10. Can we change it to 15? 50? 50?
Yeah.
Okay, let's see. Okay, so that's right there. You have a lot of space in here. Yeah, we probably don't need to go as far as 50. Let's go 20. Okay, let's go 20. Okay, good. Now we can really see the x-intercept there. So now we have a y-intercept, whatever that is, and an x-intercept, whatever that is. Okay. So let's figure out the y-intercept. What's the y-intercept? How do we do that? Second function is 1, x equals to 0. Press enter. So the x-intercept is 165. So 165 up here. So let's, how can we do this? We can have 10, 20, 30. We need to go up to 165 there. The scale would be, you can go by 20, 40, 60, 80, 100, 120, 140, 160. This is 165. 0, 165. I'm gonna stop there for a second. What does that mean? 0, 165. It means 0 days, $165 left. So how would we interpret that? It means at 0 days, he has $165 amount of money. Does that help? Is that okay? So that's the meaning, that's what the y-intercept represent. It means that's what he started off with. Okay, so this is the meaning of the y-intercept. At 0 days, $165 left. What about the x-intercept? Well, let's figure out what the x-intercept is, and then we'll figure out the meaning of it. How do we do that again? First, we gotta go to y2 equal to 0, so that's the first thing. And then we're gonna go second function, trace, intersect. They're gonna say, is this your first curve? Yes. Is this my second curve? Yes. So press enter, and then press enter again. What does that mean? 19.41 days. So I need to go as far as 19.41 days. Oh, almost 20 days. I gotta change my axes here. I need to go up to 20 days. So 2, 4, 6, 8. So 19 would be right there. draw the line. So the x-intercept is 19.4, comma 0. So 19.4 days, $0 left. Ooh, $0. So what does that mean? It means on the 19th day, he's gonna have $0 in his pocket. Okay? So in this particular case, state the domain and the range. So domain are the number of days, possible number of days, and range are the possible dollar amount. Okay, so what are the possible days? From 0 to 19.4, from 0 to 19.4. So because these are the amount of specific number, we're going to put a square bracket, and then the possible amount of dollars, that's going to be from 0 to $165. 0 to 165. So this is from possible Y values. Okay. Is everybody okay with that one? Yeah. How much money does he have after 5 days had passed? So how can we figure that out? Yeah, you could do the second function table, right? And you can go down the arrow, and then you can see here, 5 days, he's gonna have $122.50 left. So he's gonna have $122.50 left.
Could we also do 165 minus 8.5 times 5?
Yeah, absolutely, absolutely. We can say L. If you really like the algebra part, yeah, you could certainly do this part. Okay, you can go, how much does he have money left? So L. After 5 days, I can go 165 minus 850 times 5. And if you do that calculation, it's going to be 122.50. Yeah, certainly, certainly. You can use this as, you know, just a calculator, or you can use this algebra way. How much money does Ahmed have after 30 days have passed?
Same thing.
Okay, so now you can go, same thing, you could go down 30 days, let's see. Oh, he's gonna be like negative 90. Negative $90, right? And same thing, if you go 165 minus 850 times 30 days, he's gonna have, he's in a, yeah, that's a good word, deficit. He's in a negative, right? He's in a deficit. Okay. So far so good? Are you okay with this part? Yep. Okay. I'm gonna do letter E, and then that we're gonna call it a day. I'll call it a year. How's that? I like saying that. When will Ahmed have $100 left? Okay. Now here's what we're gonna do. The dollars left, we're gonna go Y2 equals to $100. Okay, we're gonna do Y2 equals 100. In this particular case, this calculator, we can enter the X, it will calculate the Y. But now if we have the other way around, if we have the y, it cannot calculate the x, unfortunately. So what we're gonna do is we're gonna go y2 equals to 100. Okay, y2 equals 100. Now you're gonna see two graphs. The first graph, and then the y2 is your horizontal graph. That's the y2 equals to 0. As you can see here, there's going to be a point of intersection in here. What we're going to do is we're going to do the intersection of two of those two graphs. So how do we do that? Second function trace. And then we intersect. 5 intersect. Okay. So 5 intersection. It's going to ask us, is this your first curve? Well, there are only two curves in here, right? Y1 and a Y2 curve. So this is your first curve, Y1, yeah. Is this your second curve, Y2 equals to 0? 100 rather? Yep. Press enter, and then press enter again. And it's gonna tell us it's gonna take 7.65 days. So it's probably around, so it's gonna take 7.65 days when he gets to 100. Now, we might have to round it off properly, because if you go 7.65 days, that doesn't look like it's a real day, right? So you can say on the 7th day, he will have approximately $100. So on the 7th day, he will have approximately $100. Okay, because 7.65 days, that's rounding it off properly would be better. How do you feel about that? There's a little bit of context in here. Today we kind of focus on using the table of values to kind of guide us with our graphs. So I'm gonna stop right here. Have a great winter break. We'll pick up on Monday, January 6th, not next week Monday, okay? Have a good break, everybody. I'll see you January 6th.